Sir, am I audible?
Yes,
Yes,
you are
ma'am.
audible.
Yes, ma'am.
Good evening to all esteemed educators present here. As Mark Van Doren beautifully said, the art of teaching is the art of assisting discovery, and today, in the faculty development program, we embark on a journey of discovery, learning, and growth together. I, Madhumita Gupta, welcomes you all on behalf of IAC, IET, and Applied Science Department of Sage University Indore to the fifth day of this enriching faculty development programs. As our keynote speaker for the day are Mr. Vijay Bhausar, Scientific Officer FDAE, RRCAT Indore, and Mr. Madan Mohan Jaina's Senior Manager Product Engineering, Daimler India. May I now request Dr. Satyendra Sharma, sir?
Ma'am,
Uh,
please call Dr. Amit Bhakar, sir.
okay, sir.
Yeah,
Sure, sir.
thank you. Thank you.
May I
So,
now request uh, Dr. Mr. Amit Bahikar, sir, to welcome our esteemed keynote speaker.
Thank you, Madhumita ma'am. Am I audible?
yes, sir.
Hello? Yes, yes. Sir.
Yeah.
On the behalf of the Sage University, Department of Mechanical Engineering and Department of Advanced Computing, we heartily welcome Mr. Vijay Bhausar sir, uh, Senior Scientist, RR CAT. Heartily welcome, sir. Heartily
Thank you, sir.
welcome
Thank you.
in the fifth day of FDP session. So last 4 days, our participants is learn so many things regarding the EV technology, their how they manufacture, how they perform. That supply chain also they learn. So today we have very nice topic that programmable power converters we will learn. So I hope that our participant will take very much benefit with this topic for their research and for their career growth. So over to Dr. Satyen sir for the uh, that introduction of the Vijay Bhausar sir, and please proceed further. Thank you.
Thank you, sir, Amit sir. Mr. Vijay Bhausar, sir, is a scientific officer F at the Laser Electronics Division, Raja Ramanna Center for Advanced Technology in Indore, with nearly 3 decades of experience in advanced electronics and power systems. His research focuses on embedded controllers for power supplies in solid-state lasers, diode lasers, and fiber lasers, as well as instrumentation and control for laser material processing in the nuclear field. He has over 42 publications and has received multiple DI Excellence in Science, Engineering, and Technology Group Achievement Awards from the DI of Atomic Energy and NPCIL. His session will provide valuable insights into programmable power converters, their role in electric vehicle, and their impact on efficiency and performance optimizations. Sir, welcome, sir. And with this, I request you to start the session, sir.
Thank you. Thank you very much. Satyan sir, is my screen visible?
Yes, sir.
Okay.
Sir, it's
Yeah, I want to switch off the video actually.
okay, no issues. Sir, for that, in the bottom side, you can find a video option. Yeah,
Yeah, it is stopped now.
done.
And one more screen is coming. I want to minimize that. Okay, right. Okay, so a very good evening to all the faculties, conveners, coordinators, and dignitaries
Good evening, sir.
who are online and listening to me. I thank Sage University and ATAL Online Faculty Development Program organizers and coordinators for inviting me for this online session. First
Welcome,
of
sir.
all, Let me introduce myself. A formal introduction has already been given by Satyanji. My name is Vijay Bhausar, and I'm working at Laser Electronics Division RRKit for past more than 29 years. My major work is design and development of controllers for switching mode converter based laser power supplies. The topic for my today's presentation is programmable power converters, and the theme of the program is energizing sustainability, electric vehicles and their contribution in environmental conservation. Although EVs are not my work domain, but I will try to keep the discussion touching EVs and relevant technologies reasonably during the session. Embedded controllers is my prime work area, and my focus will be more on controllers. Now, I understand this is a faculty development program, and I presume that attendees have good hands-on on theoretical aspects. I'll keep the discussion moving on and around the conceptual outlines, and at the same time, I will try to keep a touch with the theme line of the program and topic of the presentation: programmable power converters. So today we will talk about programmable power converters. What is a power converter, and why at all power converters are needed? During the session, we'll see in what formats electricity is available and in what formats it is really required by EVs, other electrical appliances. Then we will see some basic power converters and inverters and embedded controllers required for programmable power converters, their types, and also I will put up two case studies, one for each embedded controller type. Since embedded controllers is my domain, so once again I'll repeat, I'll focus little more on that. So let us start the talk with the very first slide. I guess until last 5 days, you faculty members and others have gone and learned a lot about the energies and sustainable energy, EVs and all that. So before starting the discussion, let's think about the technical terms: power converters, programmability, EVs, etc., etc. During this session, we'll see what are power converters, what is programmability, and how they affect the performance of EVs. How programmable converters maximize the environmental benefits of EVs. Now, once we think about the environmental impact of EVs, the very first thing that comes in our mind is that EVs don't emit the smoke and harmful gases. We see the vehicles moving on and around the roads here and there, and we observe that they don't emit smoke and harmful gases. Secondly, the first impact is emission reduction. Transition from IC means internal combustion engine, like petrol and diesel cars. Transition from IC to EVs eliminates tailpipe emissions that contain carbon dioxide, nitrogen oxide, sulfur dioxide, and particulate emissions. The second impact is renewable synergy. Charging the EVs by renewable sources will indirectly reduce carbon footprints generated by conventional electricity generators, like thermal power plants, which generates electricity by burning fossil fuels that we all know. The burning of fossil fuels is the primary cause of current climate change, altering the Earth's ecosystems and causing human and environmental health problems. Here, the matter to be thought of is how much proportion of fuel, no matter it's fossil fuel or diesel or petrol or electricity in case of EV, is really getting converted into motion and how much is wasted. Efficiency. Let's talk about efficiency, fuel efficiency. Efficiency plays a significant role in reducing environmental impacts, no matter it's an EV or an ICE. The energy which cannot be converted into motion, that is kinetic energy, will convert into other things, other wastages like heat. They will generate smoke, they will generate carbon emission. I want to give an example at this point of time. When you drive your petrol or diesel vehicle, just stand at one place and press the accelerator. You will see a lot of smoke is coming out from the tailpipe, that is silencer, because you are not converting your fuel combustion into motion. So whatever energy is converted into motion will be utilized, and the energy which is not utilized will be converted into harmful matters. Let me give an example of laser system also in which I work. The laser system where I work has electrical to optical efficiency of 5%. So if I give 5 kilowatt power, electrical power to the laser system, only 250 watt of laser is produced. What about the remaining 4750 watts? It gets converted into heat, unuseful lights, and other radiations. So the conclusion is that if we improve the fuel efficiency, then we can reduce the impact of EVs and other ICE vehicles on the environment. For example, multi-fuel injection system in PFI that improves the fuel efficiency in ICE vehicles. And now the point is the programmable power converters. It improves the electrical efficiencies in EVs and thereby saving the electricity required to run the EV. This indirectly maximizes the environmental benefits of EVs. The burning of fossil fuels is the primary cause of current climatic change. So, increasing the efficiency of a power converter which is used in EV minimizes the requirement of input electrical power, and that indirectly in turn minimizes the need to generate more electricity and burn more fossil fuels. We know we have to charge our EVs from the conventional electrical supply. So we will need less power, we will need less electricity, and our generator will burn less fossil fuels. So anyhow, indirectly I can relate the power converters. They improve the electrical efficiencies in EVs, and thereby they save the electricity required to run the EV. Now, what are power converters? What exactly is a power converter? A power converter is an electrical circuit that changes the electrical energy from one form into the desired form, optimized for the specific load. The point to be noted here is converter is not a transducer. It does not change the type of energy. Like we know the transducers that convert sound energy into electrical energy, kinetic energy into electrical energy. This is not a transducer. This is a electrical circuit which converts one form into the desired form, optimized for the specific load. So after all, why at all a power converter is needed? Multiple input patterns available, multiple output patterns required. This is the need of power converters. In EVs, we get a battery to supply the energy. In the daily applications, power converters are used in PCs, music systems, TVs, mobile phones. Now, This is sure that input power is available in multiple patterns. So let's think about that. The sources of electricity, we will see the thermal power. If you talk about the thermal power, the electricity is generated by thermal power plants by burning fossil fuels. And the heat generated is used for boiling the water and steam generation. And finally, that steam generated is used to rotate the turbine blades. This is a photo of thermal power plant. You see, in almost all the electric power generators, there is a turbine, and turbine blades are rotated by generating mechanical energy, that is kinetic energy, from steam or water flow or wind. You see, this is a windmill. The energy of wind flow is utilized for rotating the turbine blades, and in this way, the electricity is generated. These are the solar panels. In this mode of source of electricity, turbine blades are not used. Solar cells generate the charging current for the battery. So this way also we can generate the electricity. And this is a diagram, a photo of hydel power plant. A big amount of water is stored in a dam, and that potential energy, that energy which is stored, is used to rotate the turbine, and this way electricity is generated. And one more source of energy is nuclear energy. Nuclear reactors work on the principle of nuclear fission and are used to generate the electricity. In nuclear power plants, the heat is generated by nuclear fission, and this heat is utilized for steam generation. And finally, that steam is used to rotate the turbine. This is a photo of nuclear power plant. So after generation, the electrical power is transmitted through power transmission lines at higher voltage levels. At substations, the voltage is leveled down by using step down transformers and then supplied to industries, offices, and households. Now, let's have a look on the domestic supply, which is available at our houses. It's either a single phase or a three-phase electrical supply. This is the three-phase supply. This is the single phase supply. Depending on how much load we are going to consume, we are provided this electrical supply from the electricity board. Line voltage is 400 volts, 50 hertz, and the phase voltage, which is between the neutral and one of the phases, is 230 volt. Obviously, line voltage is between any two of the lines. Energy sources in EVs are batteries, and the battery voltage for the electric scooters range from small DC voltages 24 to 60 volts, and in the electric cars it is typically about 400 to 800 volts. So a vast range of electricity levels are required in the form of voltages and currents, as we saw. EVs have mainly two electrical subsystems: electronic control units and electric traction system. There are multiple ECUs used in EVs, and they require very low power levels, very low voltage levels in the order of 3 volts to 12 volts. And electrical traction system requires is high power, maybe a high voltage also, which is the main power to pull or move the vehicle. ECUs are required in non-EVs also to perform various functions. Like even if we use petrol or diesel cars, there are so many functions available that we'll see in the next slide. But when it comes to electricity is used for high power traction purpose also, the diversity in requirement of the voltage and current levels increases drastically. And this is where the need of power converters arises. 3.3 volt for a microcontroller in ECU and around 600 volt three-phase AC for maybe in one of the EVs is required for the motor to move the EV. Now, let's look in little more. An EV may have over 100 ECUs communicating for safety and comfort. These ECUs are generally microcontroller or microprocessor or DSP or FPGA based circuits. We can see here, as I said, there are many ECUs used in the EV cars for fuel control system, airbag control unit, anti-lock braking system, electronic stability. AI-based systems maintain the stability of the vehicle. Drive-by-wire systems are there, multimedia system, tire pressure monitoring. So these are all ECUs. They are used in both ICEs and EVs. As we discussed earlier, the electrical requirement of electrical traction system are entirely different from those of ECUs. Just now we saw ECUs are small circuits working on small voltages. But EVs use different types of electrical motors, each with unique characteristics that affect efficiency, power, output, and overall performance. The different motors used in EVs have different electrical requirements. At this point of time, we are concerned more with what are these requirements. Single or three-phase AC power supply and DC voltages ranging from 12 to 600 volts. So again, the thing is multiple input formats available that we saw. In EVs, batteries are there. In domestic supply, single phase, three-phase supplies, voltage supplies are there. And multiple output formats required for different motors, for different ECUs, and for different electrical appliances in the domestic use. Let's recall the need of power converters as we discussed in one of the previous slides. A power converter is an electrical circuit that changes electrical energy from one form into the desired form optimized for specific load. What are these specific loads? Maybe an electrical appliance in the house, maybe an EV, maybe an ECU, maybe an electrical traction system. Let's see what are different power electronic circuits, power converters, power inverters that provide the solution of varying available formats and varying needs issue. Now, again, to keep the theme of the program of this FDP into the consideration, we'll talk about the various types of power converters and inverters and their applications in EV. DC to DC converters, they convert high voltage DC from the battery to low voltage DC for auxiliary systems, ECUs, lights, infotainment, and control systems, and low voltage DC from the battery. Now the battery voltage has become lower from the requirement to the high voltage DCs for the traction motors, the motors used for electrical traction. Second type is DC to AC inverters. In the EV, the purpose is to convert DC power from the battery into AC power for electric motor. Next is AC to DC converter. These are used for converting the AC power from the charging stations into DC power to charge the battery. In our house also, we can charge our electric scooters and cars. And we know that the power available is AC power. So there, the need of AC to DC converter arises. Then there are bidirectional DC to DC converters. They enable the power flow in both the directions. You might have seen in electric scooters or electric cars, you should not apply the brake. For example, I have got an Ola scooter. So for braking, I have to rotate the accelerator in reverse direction. Then I can see the screen which says regenerative braking, recharging, and other applications are voltage to grid applications in households. Let's have a overview of basic DC to DC converter topologies. If we see, very basically, there are three types of converters available: buck converters, boost converters, buck boost converters. In buck converter, the output voltage is less than input voltage. And in boost converter, output voltage is more than input voltage. Just let me remind you, this is the DC to DC converter. So input is also DC, output is also DC. And in buck boost converter, the output voltage is maybe less than input and maybe more than output. If you see the mathematical expressions, in buck converter, output voltage is the duty cycle into Vin. What is this duty cycle? Duty cycle is on time upon total time of switching of the switching device. Here you can see we are talking about the switching converters. There are linear converters which are now obsolete, which are never used right now because the efficiencies are very low in linear converters. These are switching converters in which a switch is used. A switching device is used with a duty cycle, say 10%, 20%, 30%, 40%. So that duty cycle is multiplied with the Vin, so we get the output. And duty cycle is always less than 1. So we can mathematically see in buck converters, the output voltage is less than the input voltage. In boost converter, the expression very clearly indicates that output voltage is larger than input voltage. And in buck boost converter, output voltage can be less than input voltage or more than input voltage. If you see, for the duty cycles less than 50%, the output voltage is less than Vin. And for the duty cycles more than 50%, the output voltage is more than Vin. And at 50%, output voltage is equal to input voltage. Point to be noted here is all the converters require a control mechanism, a control circuitry. Why? Why? To adjust this duty cycle. In all the cases, we can control the output by controlling the duty cycle. These are very basic power inverter topologies according to the output characteristics of an inverter: square wave inverter, sine wave inverter, and modified sine wave inverter. These are the earlier inverters. In old times, around 10-15 years back, when square wave inverters were used. Then, using LC circuits and more power electronic circuitry, sine wave inverters came into the picture. And today, modified sine wave inverters are used, in which we can have a near to sine wave by using digital signal processors and generating this kind of waveform. Another classification of power inverters topologies is according to the type of load. Some of the motors in EVs, if we talk about EVs, need single phase AC. And some of the motors, they require 3-phase AC. And you can see here, the inverters are being used for converting DC voltage into AC voltage. DC voltage into AC voltage. We'll not go into the depth of the circuit operations, but here also the point to be noted is the control is required. Okay, so we have come to the conclusion that control is required. Now, let's wind up the discussion on power converters, inverters, motors, EVs, etc., etc., and start talking about embedded controllers for power systems. Now, these slides onwards, we may observe a little disconnect from the EVs and relevant terms, and the discussion may not be very understandable by non-electronics engineers. At very basic level, we can say there are two types of control methodologies for the controllers used for power systems: supervisory control and full digital control. Supervisory controllers have limited functionality. They are like supervisors. They monitor the system and issue the instructions. Like a supervisor you might have seen in a workshop or in a house construction site. Supervisor monitors the processes and issues the instructions, but it is not directly involved in the control process or process controller. The actual control action is performed by process controllers. In supervisory control, these process controllers are analog controllers. And fully digital controllers, the controller itself is involved in the control process. We will talk now. Let us have a look on the block diagram of supervisory control. In supervisory control, we can see the controller is analog controller. The microcontroller or microprocessor, which is the embedded controller in this case, is just keeping an eye on what is happening in the process. It is not directly involved in the control process. It provides a user interface. We can say a friendly user interface, graphical user interface for the user for entering the set or desired value of the parameter that is to be controlled. Now, if we talk about EVs, this interface, user interface, may be an accelerator, maybe a button for climate control, maybe a pedal for braking. So now we will talk about the power controllers, power converter controllers only. So let's keep the EVs little apart for some time. This microcontroller or microprocessor provides the user interface. User enters the desired or set value of the parameter that is to be controlled. And embedded controller provides the isolated digital signals to the DAC, which in turn generates the analog reference signal for the process controller corresponding to the set value by the user. The set value is stored in the memory of embedded controller in binary format. A microprocessor, let me define a microprocessor. Microprocessor is a programmable logic device. It's a discrete device. It's a sequential device which takes the instructions from the memory, processes the data according to the memory, and outputs the data through output ports. So conclusion is that microprocessor and microcontrollers, they are logic devices. They understand the language of only ones and zeros, that is binary format. So whatever user enters is stored in the binary format in the microcontroller. That digital data is isolated and given to DAC, and a set value or analog reference is generated for the analog controller. Analog controller compares the set value with the feedback of actual value to generate the error signal. And the control action is generated by the analog controller as per the control law. This control action is in the form of PWM signals. We just saw in the previous slides the duty cycle. So this analog controller then adjusts the duty cycle to be given to the switching device of the power converter. Now, what are PWM signals? PWM signals are pulse width modulated signals with adjustable duty cycle. And what we had seen, the basic power converter topologies, output is determined by the duty cycle of the switching device. We can say this loop is analog closed loop system. This is an analog closed loop system. Apart from that, various fault signals are required using isolated digital signals on input port of the embedded controller. And safety interlocks are provided using isolated digital signals from the output port of the embedded controller. Now, let's review the functions of supervisory controller. Generation of reference signal from analog for analog process controller is set by the user. This we saw. Generation of analog reference signal. Detection of various error conditions and providing safety interlocks. These are the error conditions detected through logic signals, and they are isolated and provided to the microcontroller. And then these are isolated and the safety interlock action is taken. Interface with user interface or HMI. HMI is human machine interface. Now, coming to the full digital control, let's have a look on the block diagram of a full digital control. We can say programmable converter. The topic of today's discussion, programmable converter. In the earlier case of supervisory control, the controller performs in programmable output mode. The output could have been programmed by the user by programming various set values. So, now, in full digital control, along with the output, the controller itself is programmable. In other words, complete or full digital control. In the block diagram, we can see there are no other analog circuitries except isolation. There is an embedded controller and power converter. Only isolation, which act as buffer for this full digital control, which is now you can see in the supervisory case, a simple microcontroller can be utilized to suffice the purpose. Here, a digital signal controller or a digital signal processor will be required, and everything will be taken care by this embedded controller. You can see only power converter, only programmable, only digital signal controller. In full digital control, unlike the supervisory controller, the control action, that is PWM, is generated by the embedded controller itself. We can see here the PWM signal was being generated by the analog controller. Now, the PWM signal is generated by the controller itself. In supervisory control, the feedback was given to the analog controller. Here, in full digital control, the feedback is isolated first and given to the digital controller. So now this is the digital control loop. In the previous case, we saw it was an analog control loop. And very similar to the supervisory controller, here also various fault signals are required using isolated digital signals on the input port, and safety interlocks are provided using isolated digital signals from the output port of the processor. Let's review the functions of a full digital control. Acquisition of feedback of actual output this way. So the feedback is acquired by the digital signal controller. Comparison with the set value. Set value is set by the user using user interface. Generation of PWM as per the control algorithm. Generation of PWM. Detection of various error conditions and providing safety interlocks, and interface with user interface or HMI. We can see and analyze that full digital controller or programmable converters are far advantageous over supervisory controllers. Let's talk about the advantages. Software defined control. Digital control algorithms reside in the software, not in the hardware, enabling easy parameter adjustments and modifications without changing the hardware. This analog controller is implemented using analog circuits, including operational amplifiers, resistors, capacitors, and others. Here, the control algorithm resides in the software, enabling easy parameter adjustments and modifications without changing the hardware. In supervisory control or in analog controller, whenever there is a new control law evolves, or suppose we get a new scheme to improve the efficiency of the power converter, we have to change the resistors, capacitors, and maybe the operational amplifier ICs to implement those changes. In case of full digital control, this is a software defined control. This simplifies fine-tuning and adaptation to dynamic load conditions or varying operational requirements for better efficiencies. We were talking about the efficiencies of the power controller, which reduces the impact of ICs on the environment. Scalability and reusability. Once a standardized hardware is designed, and software platforms allow for scalar designs and easier adoption. The same hardware, once designed, can be utilized for many versions. I can give an example of the digital storage oscilloscopes we are using. The same oscilloscope hardware device, an appliance is provided to us with a specified bandwidth, say 1 gigahertz. And the vendor says, if we want to upgrade the bandwidth to 2 gigahertz, the hardware need not be changed. Only through the software, it can be upgraded. This advantage can be exploited in case of EVs. Without changing the much hardware, for improving the efficiency, the software algorithms, digital control algorithms can be updated for the same hardware. And for the same hardware can be utilized for many versions, 1, 2, 3, 4, like we see in our mobile phones. Digital controller can seamlessly integrate with other components via communication protocol, facilitating data exchange, remote monitoring, and automated control in complex systems. In EVs, we can say better control algorithms can be updated with or without wired connections. With wired connections means you have to bring the EV to the workshop. But if it is a wireless connection through cloud or through mobile data communication, it can be updated without wired connections through and you don't have to take the EV to the workshop. Like I can see, I just told you I have an Ola scooter. It gets updated through Wi-Fi, through software. You don't have to carry the EV to workshop. Then a technological reason, electrical reason, digital control system is less vulnerable to spurious signals. Logic circuits have a noise immunity. Electronics engineers might have studied in TTL and CMOS and all other recent logics. They have got a noise immunity. So small noises can be avoided in digital systems. But in analog systems, noise can affect the performance drastically. It is also less vulnerable to drift caused due to aging of components in analog controller. Not only aging drift, but also temperature drift and environmental drift. Now, let us see what are the basic requirements of the embedded controllers. An embedded controller can be implemented using a microcontroller or a digital signal controller or a digital signal processor. So the heart of the system will be a microcontroller. We are seeing three terms here: microcontroller, digital signal controller, and digital signal processor. Let me review about what are these different things. In microcontroller, the emphasis is more on data transfer. When we see electronics students and electronics engineering faculties would be there, when we see the instruction set of a microcontroller, we will see the maximum instructions are data transfer instructions, move, like that. And digital signal processors have emphasis on computational instructions. Like big computation instructions will be there and data transfer instructions will be very less. Digital signal controller is a combination of both. It has the combined capabilities of a microcontroller and a digital signal processor. Then the embedded controllers should have higher clock speeds and throughput, that is mega instructions per second. Now again, electronics engineers and faculties can understand what is the throughput. At the same clock, one processor has some mega instructions per second and some processor may have more mega instructions per second. How many clock cycles are required to execute an instruction? How many machine cycles? How many instruction cycles? This kind of terms we might have seen in the academics. Now there are two types of processors: RISC and CISC. RISC is reduced instruction set computers and CISC is complex instruction set computer. An 8051 microcontroller is a CISC. It has got more than 250 instructions in the instruction set. And a PIC microcontroller of microchip is a RISC. It has got 35 instructions, around 35 instructions, and almost all the instructions are single cycle instructions. The control unit of RISC processors is hardwired or matrix based, and the control unit of CISC processors is micro memory based. So obviously CISC processors are slower processors. RISC processors have more throughput. Generally, when we design the embedded controllers for power converters, for user interface, we use CISC processors, and for system control, process control, we used RISC processors. And now recently I have seen dual core processors are also available, in which on the same chip RISC and CISC both the controllers are available. I have seen Texas Instruments DSC, digital signal controller, which has got an ARM core for user interface and a DSP core for computational purpose. Moving ahead, the microcontroller which is used for embedded controllers should have on-chip data converters, ADCs and DACs, with good resolution, low nonlinearities and errors, gain errors. These data converters are required because whatever we control, whether it is a power converter, whether it is a mobile phone, whether it is a washing machine or any electrical appliance, they all are analog. And the controlling device, microcontroller, is a digital device. For example, if you consider a music system, music systems are now microprocessor based. We can change the voice patterns, we can increase the volume, we can decrease the volume, we can store, we can recover. So, and the sound is an analog quantity. So data converters are the prime requirement of such controllers. They should have large random access memory to store the acquired samples. Very large RAM. Should have an on-chip direct memory access TMA module to facilitate the data transfer between ADC, DAC and RAM without central processing unit assistance, without CPU assistance. DMA facilitates the data transfer without CPU intervention. Generally, in microcontrollers, when we read the ADC first it goes to the on-chip register of the processor. Then we can save it to some RAM location. But in case of DMA modules, like when I was using DMA module in one of my embedded controllers, where 16 channel ADC was there, and at 16 locations, the ADC writes to all the locations, and then an interrupt is raised. And meanwhile, we can perform other operations using the CPU. So CPU can be utilized for other operations and not only involved in reading the ADC and other things. So DMA module is must for such controllers. Then they should have on-chip pulse width modulation modules. We just saw in full digital control, the PWM is generated by the processor itself, controller itself. No analog PWM module is required, should be required. And pulse generators also. Some power converters are frequency controlled. Some power converters are PWM controlled. So our processor must be facilitated with all these modules because our intention is to reduce the electronic circuitry, only the process and the processor. Controllers should have standard IO ports like RS-232, USB, CAN, controller area network, and wireless ports like ZigBee for interface with GUI, HMI, and Internet of Things for better connectivity. They should have good and consistent software and hardware support from the manufacturer. They should have DSP instructions like MAC instructions and wide accumulators for extensive computation if required by the application. So now we are almost at the end of the discussion. At this point of time, we have reviewed basic power converters, their need, various power sources, and embedded controllers. In two types of embedded controllers we have reviewed, supervisory controllers and full digital controllers, that is programmable converters. Now, I would like to present two case studies to all of you since it's already 7:15 and I also have some occupancy. So I will go a little fast in these case studies. These cases are two of my projects in which embedded controllers for the power converters for flash lamp pumped quasi-CW NDR laser were designed, developed and installed at various R&D centers of Department of Atomic Energy, and nuclear reactors, that is Nuclear Power Corporation of India, for laser cutting and welding applications. Case study 1 is about supervisory control, and second case study is about full digital control. So let's talk about case study 1 first. This is the automatic control and interface for dual flash lamp pumped solid state lasers with adjustable pulse parameters. This work was presented and published in National Symposium on Instrumentation in year 2011 at VTU Belgaum, Karnataka. So this is the introduction part. It says power source for lasers are high current, high peak power switch mode power converters. Function of automatic control and user interfaces. User interface, as we saw in the block diagram, reference voltage waveform synthesis, because this is not the set value is not a DC value, because this is a quasi CW laser which is consisting of rectangular laser pulses. Rectangular means you can adjust the amplitude, you can adjust the duration, and you can obviously adjust the repetition rate. And for some applications, say 100 pulses are required, so burst number should also be adjustable. It provides the system monitoring, safety interlocks, and generation of timing signals for current pulses, because the output of this power converter is current pulses of the set pulse parameters in shapes set by the user. This is the simple block diagram. You can see the embedded controller is a microcontroller, 8051 MCS51 family based controller, which has a lot of peripherals and memories on chip. And as we had seen, this is the analog controller, PI controller. This is the analog. This is a dual channel controller. So there are two analog controllers, two serial DACs, two optical isolations, two error amplifiers, and two interlock circuits, which provides the fault signals to the microcontroller through the input buffers and isolation. There are chiller units which are used for cooling the lamps and the laser rods. So this is a supervisory control. This provides the reference signal to both the controllers, this PI controller, this PI controller. 8051 is the heart of the system, which is a microcontroller. The design has been implemented using that microcontroller. In the present work, microcontroller operates at 3.3 volts. So power converter is used for generating 3.3 volt from the line input voltage. And the crystal frequency is 22.1184 megahertz. The throughput is 100 mega instructions per second. And microcontroller provides programmable of laser operation that we had seen in the supervisory control, that the output parameter is programmable, various pulse parameters and shapes. These are some specifications of the 8051 microcontroller: 128 kb flash ROM, 8 kb RAM, 64 kb interface, 12-bit data converters, ADCs and DACs, analog comparators, 64 IO pins, as we had seen in the requirements of the embedded controllers, 5 general purpose timers, UART port, SPI ports. So everything is there in this microcontroller. We can program the modes of laser operation: simple mode and complex mode. In simple mode, laser pulses are simple rectangular pulses with adjustable width, amplitude, and repetition rate. In complex mode, one laser pulse consists of many rectangular segments with the adjustable parameters. This is the experimental setup. These are the two power converters. This is the controller which is converting this and this. These are the waveforms which are measured on Lacroix LP142 100 megahertz DSO. This is the simple pulse and this is the complex pulse. These are some screenshots. We were talking about the user interface, friendly user interface. User can adjust the current, duration, and repetition rate. Here you can user can adjust the segments. He can program the segments also, amplitude and duration. These are some presets. If he doesn't want to adjust here, some preset values are already stored in the memory of the microcontroller. Now, case study 2 is a little more complex. It's a digital signal controller based scheme for interface and digital control of flash lamp pumped, quasi-CW and DR glazer. So the power converters are same, flash lamp pumped, quasi-CW and DR glazers. But the control scheme is now changed. So this is my second case. This is my second project. This work was also presented and published in International Conference on Instrumentation at Cummins College of Engineering for Women, Pune location. This is the abstract. We can skip this. This also we can skip. High current, high peak power, switch mode power converters. This is the requirement. Advantages we have already seen. This is the block diagram of the controller. In this also you can see there are only buffers, only isolations, just one microcontroller, digital signal controller, and the converter, power converter. This is the load. Feedback, input feedback is acquired by the controller, and it is processed as per the set value set by the user, set parameters, and the control action is taken as per the control algorithm stored in the memory, programmed in the memory of this DSC, and isolated PWM is provided for power converters. And again, these fault signals are acquired after isolation, and they are logical signals, and interlocks, safety interlocks are also provided after isolation. For instance, we can compare. There were so many analog circuits used. Here, only the digital signal controller and power supply. This isolation is must, because as we had seen, in EVs also the ECUs work on very low voltages, very low powers, and traction system work on very high voltages and very high power. Similarly, this converter is working at very high voltages. For an instance, I can say for triggering this lamp, a 30 kilovolts pulse is required, and to maintain the pulses around 10 kilowatt power is required, and voltage levels are also very high. So we have to isolate the controller from the converter. You can compare these two. This is the supervisory control. This is the full digital control, complete digital control, or this is a programmable converter, which is the topic of my today's discussion. There are two types of digital control design available. One is direct design by emulation or digital design, and second is direct digital design. Electronics engineers can understand, once the controller is designed in analog domain, it is in the S domain, and digital design is in the Z domain. So there are two techniques. If there is an already existing analog controller which is designed in S domain as a legacy system, you can redesign that system in digital domain using design by emulation technique. And otherwise, you can study the whole system, the whole transfer functions and controller requirements and control parameters, and directly design in the Z domain. This system is using design by emulation technique. This is again a theory. So this is a line diagram or control system diagram of the controller, in which this is the switch. The output is D, output is VPWM, D into V in. This is the output filter, which is an LC filter. The transfer function of LC filter is evaluated as this. And for the required control system parameters like rise time, settling time, steady state error, closed loop bandwidth, percentage overshoot, the controller is designed in analog domain. In S domain is this. This controller can be transformed into the discrete domain using a bilinear transformation method, in which you can convert the S parameter into Z parameters. And this is the converted transformed transfer function of the controller. This is of the controller, not of the filter. And this equation simplifies to this. And when we take the inverse Z transform, we can have a difference equation in which this is the present duty cycle, this is the previous duty cycle, this is the present error, this is the previous error. This equation can be implemented in the software and stored in the memory of the digital signal controller. This is the advantage. Now, this is again an implementation using, this is the processor, and sampling is done by ADCs. Acquired samples are stored in random access memory and DMA module has been used. Pulse PWM signals are generated using on-chip output compare modules and timers, and user interface has been designed using 5.7-inch TFT with 256 colors and resistive matrix based touch panel and interface on the UART of the microcontroller, and the baud rate is 115200. System software has been written in C language and compiled using C30 compiler of the microchip. This is the snapshot of, this is the development board on which this processor is installed, which is DSP 33FJ210. There's some number is there. And the name of the development board is Explorer 16 development board. This is the tabletop experimental setup. This is the power converter circuit using big capacitors. And this is the observation, instruments. Now, I come to the end of my talk. Since I'm in hurry, I'm sorry I had to skip a few slides and pass in hurry. My message for faculty members, this is a faculty development program. As educators, we stand at the forefront of academic excellence, guiding and inspiring the next generation of technocrats, engineers, thinkers, and innovators, our students. The world of education is constantly evolving. Every new day, a new technology is coming, AI, ML, data science. So must we. We should also evolve. By adopting new approaches to teaching and fostering the learning environments, increasing the environments, we can ensure that we are not only imparting knowledge, but also inspiring curiosity, critical thinking, and a lifelong passion for learning to the students. Let this program be an opportunity to collaborate, share ideas, and reimagine the ways we approach education. Together, we have the power to make a lasting impact on your students and your institution. Thank you for your dedication, commitment to continuous growth. Let's embark on this journey of learning and transformation together. Thank you so much.
Thank you so much, sir. Can we take only one query, if you allow?
Yeah, you can take, but only one query. I have to leave actually.
Yeah, we can understand.
But I can entertain one query.
Yeah. Thank you so much. Rajesh sir, you can unmute yourself, please.
Yes, sir. Yes, sir. Thank you. And Dr. Saab, first of all, the session was very informative. And I have, sir, a brief question.
Yeah.
That how do programmable power converters enhance energy efficiency in case of EV charging and power management?
Ritesh, your name is Ritesh, Dr. Ritesh, right? Tiwariji, what we have seen in programmable converters, the control algorithm is stored in the memory. So,
yes, sir.
Say today we have gone through one technique for some efficiency, and tomorrow we evolve with a new control algorithm for better efficiency. So without much efforts, without spending much energy, we can update the control algorithm. So this is an ease. This with the ease you can contribute, you can to improve and to update the efficiency of the power converter. This is what is the theme of this presentation.
Okay, sir. Thank you. Thank you, sir.
Yeah, welcome.
Thank you very much, sir. Sir, as you have little time, so on behalf of Sage University and Institute of Engineering and Technology and Institute of Advanced Computing, I thank you very much, sir, for sparing your valuable time and sharing your knowledge. So the session was very informative.
My pleasure, sir.
Yeah. Thank you so much, sir.
Okay, thank you. So, Satyan sir,
yes,
is there any formality remaining, or I can leave?
Sir, you can leave.
Okay, thank you so much.
Thank you
all.
so much.
Thank you all for listening with patience. Thank you so much.
Yeah. So,
thank you, sir.
Thank you, sir. So now our second speaker has already joined. Mr. Madan. Madan sir, are you? Oh no, maybe. Sir was joined. Let me call him. Please wait. Hello, Mr. Madan Jaina. Sir, have you joined?
Yes, sir, join.
Okay, okay. So thank you very much, sir. Uh, I'm making you co-host so that it will help you in sharing your presentation. And
Okay, sir.
before starting, I request Dr. Amit Bahekar, sir, for welcoming. Amit, sir, it's over to you,
Yes,
sir.
sir. Yes, sir. Yes, yes, sir. Yes, sir. On behalf of Mechanical Engineering Department, Sage University, and Department of Advanced Computing, I heartily welcome Madan Mohan sir. Heartily welcome, sir. Uh, am I audible, sir?
Yeah,
I
yes, yes,
think
yes, you
Madan
are
sir
audible.
or Madan sir
Uh,
is sharing on
there may
some
be some network issue.
network issue.
Yeah, yeah. Maybe.
I would like to say that Madan Mohan Jena sir is the alumni of Sage University, and I think he's presently working in a very that reputed company, that sister concern company of the Mercedes Benz. He is working there. I think he's in R&D department or some department is working. I have read his profile, so he is
Yeah,
presently posting in Chennai. So is he joined or not?
just wait.
Yes, yes, sir,
Madan sir.
join.
Aha, Madan sir,
Okay,
am I audible?
Yes, sir, audible, sir.
Aha.
okay.
So just I want to welcome you heartily on the behalf of the Sage University Mechanical Department and Department of Advanced Computing. Heartily welcome.
Thank you, sir. Thank you. Thank you,
It's
sir.
And
after very long time.
thank you for sharing time for us. I know you are acting under training in Chennai somewhere in Mercedes Benz also. I heard that. So in spite of that, you have spare the time for us. It's very uh, good. Thank you for us. Eh? And now I request Satyan Sharma sir
Yeah,
to introduce to read that introduction of the Madan Mohan sir and proceed for the session.
yeah, yeah. Thank you, sir. Thank you, sir. Actually, he is very busy,
Yes, yes,
but
yes.
even
That's
then, he has spare time. Yeah,
yes. I think in Chennai. He's doing some
yeah,
training work.
yeah. So, I request Professor Gautam Singh, sir, for formal introduction. Mr. Madan. Gautam sir.
Good evening, everyone. It is my pleasure to introduce our esteemed speaker, Engineer Madan Mohan Jaina. Uh, Madan Mohan Jaina is an automobile industry expert with 14 years of experience in vehicle testing, automobile market study, production, customer field quality, and engineering. He is currently a project engineer at VE Commercial Vehicle Limited, a Volvo group and Eicher Motors joint venture, where he plays a key role in vehicle validation, durability testing, and performance optimization. His expertise include instrumentation and data acquisition, root cause analysis, digital validation, and benchmarking of automotive components. He has conducted extensive vehicle performance studies, fuel economy trials, and real-world application testing across global markets, including Africa and Middle East. His session will provide valuable insights into data-driven vehicle performance testing, focusing on the role of validation techniques in enhancing electric vehicle efficiency and reliability. Now, I request to Mr. Madan Mohan Jaina to start the session.
Thank you, Gautam sir.
Yes.
Now, Madan sir, the session is over to you, sir. You can share your presentation.
Hello, good evening, sir.
Yeah. Good evening, sir. Please.
Good evening to all of you. It's my pleasure to join this national level one innovation activity, which will help me to definitely share my experience, last 14-year experience in vehicle testing and capturing data. And right now, data is oil, data is everything.
Correct.
So it will help us in any segment. The data will driven all the industry. It's not only about auto industry, it's all about medical, hospital, yeah, any mechanical field, any data subject, any field. If you'll go, if you have data, then only the industry will run very well, smoothly with new technology. So data is the new oil of the world. So how the data will impact in automobile segment, whatever I learned today till today, that I will share with all of you. Definitely, I have some personal, so lately joined. Sorry for that. And we will start with how the data will just introduce first. I will inform how to what is data, then how the data will utilize in our automobile segment. So is my audible? Visual video is audible visible?
Yeah, sir. Your presentation is on the screen.
Okay.
Little bit, if you can increase the size percentage of the.
Okay, fine. Is it visible?
Yeah, it's visible. Yeah. Now it's better. Perfect.
So this is only for this segment. What I learned that I converted in words, and also some PPT also I have prepared. Based on that, we will discuss. And if any doubt, then definitely we will stop at there and we will discuss. Okay.
Sure.
So data-driven vehicle performance train. Data. All just last what I told. Data is the new oil. So the data for vehicle is more important to improve as soon as possible the vehicle development, to reduce the cost, to reduce the failure of vehicle, and increase the performance of vehicle. Also for new technology development, data is more important. So how, during testing, what I learned, whatever the data we are capturing, initially to understand the vehicle performance, but after that what we understand, this data only it helping us to develop and understand the vehicle characteristic, how the vehicle is behaving. So then after that, we started from last 2-3 years capturing all the data, gathering the all data, and how the data we can utilize to new development in our new upcoming products. So data in data involving landscape of the automotive industry, data driven vehicle performance testing has emerged as a game changer. Gone are the days when vehicle testing was solely dependent on the manual observation and subjective evaluation. Today, advanced data analytic, sensors, and telematic have transformed how manufacturers, engineers, performance analysts evaluate the true capability of the vehicle. With the integration of cutting edge technology, data driven testing has significantly enhanced accuracy, efficiency, and reliability in assessing the vehicle's performance across the various parameters. So, for capturing data to understand vehicle behavior, nowadays we are using all the vehicle as per government norm also, it's compulsory now. We are using new GPS technology. So with the GPS technology, telematics, it's called telematics. In vehicle, all the sensors, all the ECUs, electronic control units, all are integrated with telematic units. So whenever wherever the vehicle is running in anywhere in the world, if the telematic is connected with the data center, then from there we can understand the vehicle, how is the vehicle performance, which sensor is problem, what aggregate is vehicle aggregate is problem, and how our vehicle is performing. Based on that data, we all the industrial leaders or industry company OEM original equipment manufacturing owners supporting to customers, helping the customers to reduce the vehicle breakdown. Also, meanwhile, they are studying the data and improving the aggregate product performance and vehicle performance, understanding how the customer utilizing vehicles during real world application, understanding the vehicle application, understanding the driver behavioral, and based on that, they are designing the product based on because India is the cost sensitive market. If you want if you want to survive in Indian market, definitely cost is a major factor. So to reduce the cost, to optimize the vehicle performance and increase the vehicle aggregate life, understanding customer application. When a customer purchasing vehicle, might be he will utilize the vehicle in different application, like suppose truck having different segment tonnage wise, from LMD, HD, and LD in the sense that below 6 tonner is that LD, and LMD means light medium duty vehicle, which one is like 7.5 to 20 tonner. Then is next is the HD segment. HD is 20 to 55 tonner, and after that ultra, like my ultra HD vehicle, that is like mining, which one more than 55 tonner vehicles are there. So when customers are purchasing vehicle in different segment, different applications are there. So we must have understand why, for what customer is purchasing the vehicle. To understand that, now the data is playing crucial role in this segment. So what we are doing, we are capturing the data with help of telematics, and we are doing improvement. We are helping to customer how you should be run the vehicle. If vehicle is loaded, on which speed you must be run. If there is a traffic, how you will slow down the vehicle, how you will again accelerate the vehicle, how the customer where due to less FE or vehicle aggregate, if that damaging, then for what it's damaging. With help of those data, we are informing to customers and changing the driver behavioral, improving the vehicle product and product life. So the role of data in vehicle performance testing. At the heart of data-driven testing lies the collection of analysis of vast amount of data during real world and simulated driving conditions. This data comes from multitude of sensors embedded with in the vehicle, such as GPS, accelerator meter, tire pressure sensor, which one called tire pressure measurement system. Even though in TPS, it will help to understand the vehicle tire, how is the behaving, pressure, temperature, and based on the automatic, it will feel the pressure, tire pressure. So temperature monitors and much more. These sensor captures viral information such as speed, accelerator, fuel efficiency, engine performance, brake efficiency, and vehicle dynamic in the real time. The data can be aggregated and analyzed to produce insights that offers deeper understanding of vehicle performance characteristics. This enables engineer to refine designs, predict potential failures, and optimize the various aspects of vehicles to enhance the vehicle performance, safety, durability. Just I want to give an example to better understanding. See, if one customer is there who is running the vehicle in cement application. In that segment, when the vehicle, normally who are the cement segment owners, what they will do, they will send the vehicle to cement where producing manufacturing center. From there, they will load the vehicle. And cement is the product where area they are taking less area but higher weightage. So in that segment, overloading is not possible. So if the vehicle is, example, 42 tonner, then they will completely load 42 ton. Then the vehicle will run on which speed normally when vehicle is running 42, then they will average. I'm telling this data based on our data analysis performance data vehicle. Normally the customers are running 40 to 60. If the vehicle is running in between 40 to 60, we are thinking on this 40 tonner weight condition, what kind of brake, how many numbers of air train, how many numbers of liner, what is the thickness, what kind of material required, is those things we are deciding. Based on that, we are designing the vehicle and reducing the vehicle weight and increasing the loading capacity. And also with help of that, like brake, steering, other aggregates also life we are increasing. So this data, with help of this data, like on which ton vehicle is running, how much time the driver is braking during from plant cement manufacturing to the delivery point, and daily how much kilometer running, and daily how much braking, accelerating, which gear running, which speed running. Based on that, all designers are understanding their aggregate uses, and based on that, they are designing their parts. In every vehicle, for quality, for better quality, we don't want to give a higher range of high cost of all aggregate. If we understand what is the application, see, normally in cement application, what they will do, they will take the cement load to delivery end, dealer end, they will undeliver the product at dealer end, then they will come back to their in empty vehicle. There is no loading. So in that life. So based on that, wow, how much dia, brake liner, drum liner, what is the thickness of liner, those things we are deciding. In that condition, which load condition, that steering gear load, steering pressure, all those things we are deciding. And based on that, what we are doing, designing the vehicle. So with help of this data, only nowadays, all the customers like Tata, Ashok Leyland, Bharat Benz, Eicher, they are improving their products and reducing the product of cost. And with help of that, their breakdown, failure of the aggregates, their understanding before failure. If some condition they are unable to find if any failure, this condition also it was helping us to identify the root cause of the problem. So data is more important nowadays in automobile segment to understand all aggregates behaviors, how they are reacting, how they are behaving during on what speed, which speed, on which altitude, these things. So next we will go to type of vehicle performance parameter tested. Data-driven vehicle performance testing allow manufacturers to evaluate a vehicle performance in several key areas, such as acceleration and speed trials. Sensor track the time it takes for the vehicle to accelerate from 0 to 60 miles per hour, providing insights into engine performance and efficiency. Braking and stopping distance, like acceleration and speed. Acceleration speed means like every vehicle, if you go to HD vehicle, one wheel speed sensor is there. That wheel speed sensor will take the data, it will inform to ECU. Based on that, when ABS will brake, on how much braking required, it will help, on which speed vehicle is going, all the data will capture, and based on that, engine performance will increase, engine efficiency will increase during running. So this is the data of sensor data, wheel speed sensor data, and we can utilize it in real time. We can understand on the time, real time, how is the vehicle behaving. Braking and stopping distance. By analyzing brake force, deceleration rates, and stopping distances, engineers can access the vehicle's braking system and handling capability. Same exactly like fuel efficiency, one performance data is one performance trial is there, where we can understand how much fuel is required to run the vehicle on which condition, like loaded condition, how much, partially loaded condition, how much, empty loaded condition also, how much fuel efficiency coming. Based on that, engine we can simulate the engine, we can set the engine parameters, and based on that we can increase our fuel efficiency. If there is unladen condition, then how much fuel injector is required. If laden is there, then how much fuel injection required. Then the timing, that all those things we can set based on wheel speed sensor. One data, one information will come to ECU. ECU will inform to our engine all the parameters, sensors, how much you want to injection, and the timing, tapered timing, everything it will set, and based on that, vehicle performance and efficiency will increase. So fuel efficiency data gathered from engine, transmission, exhaust system allow for the calculation in real world, and the real world fuel efficiency, which helps optimize fuel consumption and emission performance. Vehicle dynamic tests, data from accelerometer and gyroscopes and wheel speed sensors enable the evaluation of handling concerning stability and ride comfort. Environmental impact, the monitoring of emissions, exhaust systems, and battery performance for the electric vehicles provides insight of the vehicle environment footprints. Next is like all these all five parameters are vehicle performance parameters, just to understand how we are utilizing the data, on which trial, how it's helping us to improve the vehicle performance. Like already till fuel efficiency I informed. Like next is the vehicle dynamic. In vehicle by dynamic also there is different type of sensor as well, like accelerometer, gyroscopes, and wheel speed sensors. Which one is automatic evaluating and informing the data to ECU, and it's helping the vehicle stability, ride comfort, and handling. Environment impact, the monitoring of emissions was already just I informed, and the monitoring emissions, exhaust systems, and battery performance for electric vehicles provide insight of the vehicle environmental footprints. Next, we will go key technologies of data-driven testing. Several technologies play integral role in data-driven vehicle performance testing. How those data, which one collecting by ECU, what is the aggregates, which one helping calculating in real time and helping us to improve the vehicle performance. This one is telematic, next is vehicle simulation softwares, machine learning and AI technology, advanced sensors. There is so many advanced different sensors, multiple sensors are coming. We will discuss on that. We will go to telematic first. What is telematic? Telematic, you heard somewhere like now is government is going to rule like all the toll tax, no, they will close the tax area. How they will charge, like based on telematic data. Now the telematic is already compulsory and government is going to compulsory in all the vehicles, and based on telematic, they will, when the vehicle will cross that toll, automatically that telematic data will go to government, and automatically whatever your amount of that highway toll or state toll, automatically it will deduct from customer's account. So here like humanless toll taxes, toll stops will come. There is no, in that case, what will happen? Uh, all the customers, like all anywhere, any customer must be pay when cross the toll, and with help of GPS technology, and also then no need to wait for long time for the vehicle to cross the toll.
Maybe some network issue. Yeah, sir is rejoining. Video has connected, but audio is not connecting. Please wait. Yes.
Hello, my voice is audible, Satyan sir?
Yes. Yes, sir. Yes, sir. Voice is audible. Suddenly disconnected. No, now voice is not coming. Audio disconnected.
Hello, Satyan sir?
Yes, sir. Yes, sir. Now you are connected.
Sorry, actually I am in interior area, so here little bit
Okay.
network.
No issue. No issue.
Okay, so next we will just, I think all my colleagues understand how telematic is going to play crucial role in our vehicle and all the vehicles. So with the help of this telematic, we can identify on which road, on what altitude we are going, what kind of our vehicle performing, how much fuel consumption is by vehicle. Those things, those data we will send to customer, even though with help of telematic, no, what we are doing, like diesel theft, anti-theft technologies came. Like suppose you having in diesel tank inside one floating sensor is there, which one is indicating the vehicle how much now we have fuel. So real time, if suddenly that fuel, some thief theft that fuel diesel, then suddenly that sensor will sense sudden, within 2 seconds how diesel can reduce this much. It's not possible whether we personally removed or someone theft or the tank damaged. In these three condition only it will happen. So what will happen when a sensor will sense immediately within 2 3 seconds? This is the level of right now in 7 minute 51 59 second, and 60 second it will suddenly drop. Then one alert will come to vehicle owner, your fuel level suddenly dropped. In that case, vehicle owner will immediately call to driver. He can understand the situation. Is it really fuel theft someone, or the tank got damaged, or somewhere leakage? Those things will identify by driver and inform to customer. with help of
Excuse me,
this
sir. Sorry to
yes,
disturb you. You need to reshare the presentation. Actually,
yes,
logged out, so we are unable to see the slides. You need to reshare.
yes, yes.
Yeah.
Okay, sorry.
No, no, no issue.
Okay, sorry. Disconnected. So,
Yeah. So correct.
okay. So, with help, what
No,
I'm
not.
telling, how
No,
we
no.
are utilizing the
Yet not
telematics,
shared.
it's
Uh,
not
sh-
visible, sir.
no, no. It's not shared.
No, it's
Uh, First you need to click on share upper green arrow. Then select the screen.
sorry, team. Actually, due to poor network only, I'm talking.
But yet not shared.
Hello,
Yeah, screen is not shared yet.
is visible, sir?
No. You need to select the screen, which screen you want to share.
Hello.
Yes, still not showing. First, click on the share option, then select the screen. You may be, oh no, a big network issue maybe.
Hello,
हाँ मदन सर.
Satyan sir.
हाँ नहीं
Yes, my
अभी शेयर नहीं हुआ है. अ, आप ये जो है एप्लीकेशन विंडोज में से एक विंडो क्लिक कीजिए.
actually it's what a host is not allowing to sharing the for this meeting. So I need host permission.
ओके ओके सॉरी सॉरी. यस करेक्ट करेक्ट. नाउ यू कैन शेयर. नाउ प्लीज चेक.
Sir, still asking host permission. Sorry.
No, you are already a co-host, so now you can share.
No, not supporting. Still is telling still asking permission from sharing is not. Yes, now allowed.
Hello, okay. That may be due to network issue. Yes. Now you need to open the that page. Actually, yes. Coming now.
Sorry, team, for the entrance.
No, it's not in.
So we can start, Satyam sir.
Yeah, yes, definitely.
Hello,
Yes. You can start, please.
hello.
Am I
Yes,
audible?
we are again starting. Okay.
Okay.
Hello.
Yes. It's audible perfectly.
Okay. Yes. So okay, sorry for that. Just before what we discussed, to use and to collect the data, what
You
kind of,
Network issue.
is it okay, sir? Now,
yes.
Yes, sir. Now
Okay.
audible.
due to network issue only it's happening. Sorry, team. Okay, what we discussed just before that problem occurs. So to capture the data, what the things are in vehicle helping us to collect the data. One is major aggregate is telematic. What is telematic? Just I informed before, and shortly just I want to restart just re-information. Telematic is a device which one we are fitting in our vehicle, and it's directly connected with OBD connections. OBD in the sense like all the vehicle in sense ECU. It's connected with vehicle ECUs. ECU is the full form electronics control units. Nowadays, the all sensor integrated in one ECU, and ECU is like brain of the vehicle. All engine data, wheel speed sensor data, telematic data, everything is coming to ECU, and ECU is in driving the vehicle with help of those data, we can say. So telematic is one major aggregate which one supplying the data to ECU, and also helping ECU, and it's depend on ECU also to receive all the data, and helping customer and vehicle to increase the vehicle performance in real time. So what the doing with telematic? In there is one enabled GPS is there, which one is continuously sending information to vehicle on which altitude, on which speed vehicle is running in real time, and with help of this telematic system, continuously we are monitoring of vehicles performance through wireless communications. Inside that GPS is telematic one like mobile like one SIM is there, which one is continuously supplying all the information to the cloud system of that telematic, and this system transmitting real-time data about speed, engine performance, more to a central system for analysis. It's in real time, it's very fast, and it's simulating, it's calculating all the data, and helping customers and engineers. Hello, hello, any
Nothing, sir.
doubt?
No.
Okay. Okay, it's a helping to customer and designers, engineers, and vehicle all OEM manufacturers to understand vehicle behaviors and improve aggregate lives and improve vehicle performance. Also, it's supporting to customer like the data is coming to customer. If a vehicle is over speedingly running by drivers, then information will come to the vehicle owner. Continuously message will come. If any error codes coming, any aggregate fail, the sensor will send immediate real time data to customers. Also, this error code coming, vehicle need to send service center, or need to stop the vehicle, or any like suppose in diesel tank, no, one indicator is there, diesel tank level indicator, fuel level indicator, that's called, and that fuel level sensor continuously sending data to ECU telematic. What is my vehicle, how much diesel is there, based on that it will informing to customer and driver next how much kilometer vehicle can able to run. Like suppose 10 liter is there, safety for 5 liter, then remaining 5 liter we can, if this speed you're going, example ideal speed, economy speed is 40 kmph, and then mileage will come suppose 10, then based on that next 50 kmph kilometer can vehicle run. Like this real time the data will update to driver and customer also. Suppose sometime all the customers are not driving vehicle, so the data also sending to customer application, mobile application. So it will helping customer to improve vehicle. Suppose you're overspeeding, then it will come vehicle overspeeding, and that your mileage will FE will come less. Then customer and driver both will alert and run the vehicle in economy speed. If continuously braking, then in that condition also vehicle performance will be reduced. So it will come, change the gear, change the speed, or what all the vehicle data which one required to inform to customer, it will come in real time. Next, vehicle simulation softwares are there. So many softwares are there. Which one? Like suppose in a diesel vehicle, the fuel level sensors are there. Different sensors are there. If you will come to EV, then it will come how much range will come. If the range also depends upon battery temperature. If high battery temperature and atmospheric temperature also high, then also vehicle performance will less. If more cold, also vehicle performance will less. In both, all the temperature of outside, temperature of battery, temperature of coolant, all the things, wheel speed sensor, all the data will come to ECU, and ECU will real time it will calculate and inform you how much in EV vehicle range will come, how much your vehicle, when you want to raise the vehicle, on which area charging stations are there. All the real time data will come to ECU, and ECU will inform to you through telematic and vehicle sorry the applications. Then next, vehicle simulation software. Virtual testing environments allow engineer to simulate the real world condition, including harsh weather, extreme terrain. These simulations provide valuable insights with the need for physical testing in hazardous condition. See, when we first collect the data from telematic, wheel speed sensor, and what we will do when next new projects will come. Yeah, any new development. If you like some project came, you want to run the vehicle in moon surface. What you will do if you don't have data? You can't simulate. You can't go every time to moon surface and test the vehicle, or you can design something based on moon surface. So what normally engineers are doing, they having data. What kind of data? Like how is the moon surface? What is the quality of earth, their moon surface? How much dust is coming? How much their speed, on which speed you can run the vehicle? Because in moon surface, no, there is like powder like materials are there. There is no plain hard surfaces not available in moon. So in that condition, how much speed you can run, on which speed you can run those, if data available, moon surface data, temperature data, atmospheric data, based on that you can decide from here what kind of my tire, when the vehicle will go to moon, what kind of tire material we will use, or really tire material we will use, or we will use some metallic aggregates, yeah, chain type pulley, yeah, belt type pulley. Then we can understand, if we having moon surface data, moon atmospheric data, then we can understand and we can design the product. And for designing, after design also we can't go to test the same thing in moon. So we, for simulating the data, there is simulation softwares are there. What we will do, after design the product, we, with help of this testing software, we will create the moon surface temperature, moon surface, how much thickness, what kind of materials are there, and we in a real world we will, what is the condition of moon surface, we will, all the data we will enter in the software, and what aggregate we designed, that we will run in that software, and we can understand with running almost it's 80 to 90% accuracy coming. We can understand when we will run the simulation software. In that condition, we can understand where on which aggregate how much temperature coming, what aggregates how they are behaving. All those things we can understand with help of these simulated softwares. And what we will do before manufacturing the vehicle, making the final product in prototype product, we will improve our products. Like suppose something, when running the vehicle in the high altitude area, that engine temperature is going high. So in that condition, what we will do, we will check engine which kind of metal is creating more temperature, and we will change the temperature. We will change the material. We can develop the product aggregate, change the material, change the design to reduce the vehicle temperature or engine temperature or that aggregate temperature, and we can stop the failure before going to real world. So these vehicle simulation softwares are helping us virtual testing of environment, allowing engineer and designers to simulate real world conditions. Next, we will go to machine learning and artificial intelligence. This is the one major software. Machine learning algorithms are there analyzing large data sets. Like when you collect data, it's coming like big data centers are the required. So machine learning and artificial intelligence analyzing the with help of this algorithm, it's analyze the large data sets collected from vehicle tests, identify the patterns, that applications, and predict potential issues and recommend improvement design. It will help to OEMs uh, to reduce their testing cost, because wherever you will go, a good product, then you need more. You need to spend more in designing and certification for this product. Like not only in vehicle, if any food product, medical instruments, anything, if you want to spend a lot of money in R&D, research and development. With help of these simulators, with help of artificial intelligence and learning, and with help of this data, that OEMs are running those data in uh, reducing the cost of testing costs. And these machine learning and artificial technologies, new technologies, with help of those past data, which one collected through telemetry or real world, those data is identifying potential failures and predicting and recommending to you how, where, what need to change, need to improve in our vehicle design. Next, we'll go to advanced sensors. See, to capturing all the vehicle data, no, need more advanced sensors. And those sensors only helping us to collecting. So these advanced sensors is the critical parameter and part and aggregate of our data. Example, LiDAR, radar system to GPS trackers, sensors embedded in the vehicle monitor to the road surface. It's contributing to a comprehensive understanding of vehicle behaviors. Those sensors like LiDAR and radar system to GPS tracker, what they will do, they will identify on what kind of road. They will immediately in real time they will send data to ECU, and they will calculate is any human being coming. then on which speed vehicle going, wheel speed sensor will come inform the data to ECU. Then ladder and radar both are will send their real time on which location, on what altitude, on what speed vehicle is going. And those data they will calculate immediately. They will send the information to vehicle ECU, and automatically that ECU what will do, active the brake system and stop the brake. That is ADAS and a ladder and radar. Those are helping to our vehicle system to understanding the vehicle behavior. Next, we will go benefit of data-driven vehicle performance testing. The adoption of data-driven testing offers numerous behavior of manufacturers, engineers, and consumers alike. Accuracy. Data-driven testing eliminates human errors, providing objective results that reflect a vehicle true performance under the various of conditions. It's cost effective, it's improve our safety, it's reducing our testing time, development time, it's like a faster development cycles, optimization of performance. We will discuss how these data helping us, what are the things we are uh, getting easily from this data driven vehicle performance testing. With help of those data, our testing, during testing, if a human will run the vehicle or take the data, might be sometime it will, some errors will come. But if with help of so many data, big data banks, and what we are doing, we are using algorithms and eliminating the error data and compiling the corrected data, and we making the softwares. With help of that software, our data driven accuracy, the testing accuracy is coming very high. And data driven testing eliminates human errors also, providing objective results that reflect vehicle true performance under the various conditions. Also, it's cost effective. When you will go to real world, testing multiple time vehicles, testing multiple new designs, so due to some chemical reaction, due to harsh weather, what happening? No, companies are spending more cost, and also there is some error will come. Not accuracy is less, but with help of this data, before testing, we can simulate and we can reduce the number of testing periods, and it's helping to companies cost effective. By physical testing, prototyping, extensive field trials, manufacturers can save significant amount of money on testing procedures. Yes, testing is compulsory. We can't ignore the test, but the number of test cycles we can reduce with help of this data. Improving safety, like when you are going for testing, if you want to, like suppose I don't know you all are know or not, brake is the first safety parameter of our vehicle. During brake testing, that there is a different type of testing parameters are there. Like what they will do, they will high speed testing example. Then they will go in, they will run the vehicle in high speed condition based on country to country norms. If the company that vehicle is for Europe, some country, those all European countries are high speed market, and even the Gulf also high speed market. They will run the vehicle in speed of 100 to 120, and they will check the vehicle stopping distance how much coming. When you're going to real world and testing those testing multiple time, safety is the major factor coming. Like whoever running the vehicle, whoever braking in that speed, definitely he is playing with his own safety. But to ensure the safety in regular production, we have to test the vehicle. So they are taking, the test engineers are taking risk and they are doing. But with the help of this data, what we will do, we will design our product and run the product in simulation software. With this much speed, will they will run the vehicle and immediately they will stop. And also, like in that software, that we will inform front side, this much wind speeds are coming, this is the road condition, this much load is there, this much peoples are sitting inside the vehicle, or truck means this one driver, one supporter is there, and loading condition is like this, front side load is there, rear side load is there. So you can create the scenario of the real world, how customers are running the vehicles, and what you will do, and run the vehicle in a real world condition, how customers are running the vehicle, and run the software, and you can understand if in this condition we run the vehicle, when the vehicle will stop, how much time is taking to stop the vehicle. If in we will do in simulator testing, we can identify the problem, and also we are doing corrective action without running the vehicle, and we are then we will test, and simulator test is showing it's almost okay, there is no problem, now product is perfect. Then to understand and ensuring, we will run the vehicle on that speed. With help of this data, this simulator testing, we are first of all, we reduce the multiple times testing. We safely tested, improved the driver and engineer safe, and also we identified and reduced the cost of testing, and also we identified the problem. We solved the problem also. So these data is helping improving our safety. Continuously monitoring real-time feedback enable engineer to identify potential safety issue or defects before they become critical. Faster development cycle. See, if you go to real world test, so every time you have to set the vehicle within this load the vehicle, create the vehicle in real world condition. You go to the worst road conditions. You have to run the vehicle on a real world case. So those things taking much time. If you, with help of this data, if you will run the software, it will happen within certain seconds, and the development cycle will reduce automatically. Faster development cycles. Data driven testing allow you quicker iterations in the design and testing phases, leading to faster development and time to market for the new vehicles. What will happen if you will reduce other competitors, if they will not use that data driven testings, and they will test in real world, then what will happen, it will take more time for them. Within that time, you will launch the new product. Like just some days before, what happened, chat gpt and deepseek is there. Till now all are told, like chat gpt founder told, it's not possible to develop a ai software. But with help of the data, the chinese engineers made deepseek software, artificial intelligence software, within certain time, within less cost, effectively, and it's performing very well, better than them, better than chat gpt. So hope you all understand how much costly nowadays the data, and how the data is helping designers, engineers, scientists to improve their products, improve the safety of products, less development time, and optimizing the big performance of the product. So next we will go to faster development cycle with the help of the driven testing, allowing quicker iterations in the design and testing phases, leading the faster development and time to market for new vehicles. Any product fastly come to market when you have multiple options, multiple like within see, the customer also purchasing less cost product. So with help of this data, you can reduce the testing development cost, then ultimately it will what happen, your product cost will reduce and you will the leader of market. So with help of this data, what the things are we can do, hope you understand all. So why we are telling to data is new oil, or data is the more costlier than now anything in the market, anything in the world. Hope you understand. And next point is the optimization of performance. By evaluating a vehicle performance across different parameters, manufacturers can fine-tune features such as engine performance, handling, fuel efficiency, resulting that more well-rounded the competitive products. So when the competitors in market, in that time you have a good product with less cost, with high performance, with less failures, and with improved safety and improved accuracy also. Next we'll go to challenge. What are challenges are coming? Data driven vehicle performance testing. Despite many advantages, data driven testing comes with its own set of challenges. Yes, but till now what I told, those are the advantages. But to capture the data, what are the challenges are coming? That next we will go and discuss. Data overload is the main challenge for the testing, data-driven testing. How? The vast amount of data generated can be overwhelmingly requiring advanced system for processing, analysis, and interpretation. What happens when the multiple data will come and you don't have the algorithm for simulating or segregating the data, then you will face the problem of data overload, because you have more data but you can't utilize it. And it's what happen, it will create for you you will face it will create for you you can't understand what to do with those data, how to utilize the data, which data you have. So for that, artificial intelligence machine learning technology required, need to create new algorithm and need to segregate the data, which is the accuracy of data, which data you have to utilize, which data you have to delete. Next, integration with existing system. Incorporating new data-driven technology into traditional vehicle testing system can be challenging, requiring significant investment in infrastructure. Like nowadays, what we are doing, how we are testing, like suppose brake test, then one driver will go, he having that much force, pedal force gauge, then you will what will do, you will force the pedal force within this much second, this much speed, then you will check the real world how much when the vehicle is stopping. But when you go to data-driven testing, there is multiple speed sensors are there. Wheel speed sensor will send the data to cluster. This vehicle speed, and this much speed you have to go. Then in that time you have to stop the vehicle. But when you have data, then automatically you can program the vehicle and stop the vehicle in that condition. So integration of the data, integration of new technology with existing system is more important, and it's really a challenge, because whenever I told you we can help, we can use these sensors, we can do like this, then starting mindset of will come. We will see when newly just for understanding I giving this example, when newly in toll stops vehicle, the government introduced that what telling recharge system, and then peoples are not accepted easily. To integrate that in our regular system, we created so many government run so many advertisements, awareness, then only people are slowly integrated with new technology. So it's taking time. Same in testing also. When new technology coming, new sensors are coming, it's difficult to understand those sensors if you not understand the program and wrongly testing also the wrong data will come, then also problem will create for you. Next is privacy concern. With the rise of connected vehicle and telematic system, concerns about data privacy security are becoming more prevalent, especially regarding user information gathered through in vehicle system. So whatever data collecting, if the data will leak, if the data privacy we can't maintain, then it will create problem. Like with Aadhaar card and PAN card, all the data our government having systems. When you are using any application, mobile is asking the all permissions. Then you are sharing, allowing the all permissions in privacy. But if the data privacy is not unable to maintain by those application owners, then it will leak your personal data. And with help of this with help of this with leak of this data privacy, it can happen anything with you, like where you're going, which customer from the customers are running on where which area, who having more load. If those data will inform to other customer, then your business will stop immediately. So data privacy also important, also ensured by all OEMs or all the responsible persons to maintain the data privacy. Okay, next we will go the future of data-driven vehicle performance. Before that, just I want to understand if anybody having any doubt can ask.
Participants, if you have any question, please come forward. Madan sir, I don't have any question in chat box.
Okay, so we can continue.
Yeah, we can continue. Thank you.
Thank you. Next, the future of data-driven vehicle performance testing. As technology continues to advance, the future of vehicle performance testing will be increasingly data-driven. With the proliferation of electric vehicles, autonomous vehicle driving, and smart mobility solutions, the need of sophisticated data analysis will only grow. Predictive maintenance, enhancing AI driven simulations, even more integrated sensor systems expected to drive further improvement in the vehicle performance testing. Moreover, the rise of connected infrastructure such as smart cities with intelligent traffic system will create new opportunity for gathering even more data to improve vehicle performance. These advancements will ultimately lead to safer, more efficient, and environmentally friendly for the vehicles. So, with help of those data, with integrating new technology, smart city technology, smart traffic all data, we can see when you're going from one place to another place, you're using Google Map. It's guiding you on which area, how much traffic is there, how many routes you have, if you which route you will choose, how much time will take. Those things happening with help of data only. Immediately it's calculating real time and informing us based on that customers are easily identifying on which route they have to go, on which road condition is how, traffic condition is how. It's also AI driven simulations are there. With help of this simulation, it's informing to customers, it's informing and gathering the data for OEMs to improve their product. Also for customers is helping and how to run the vehicle on which segment of which road you have to go, like same on which speed you will run the vehicle, how much braking is required, how much steering turning is required, what is the atmosphere temperature of the inside vehicle. Those things you can easily get from data driven vehicles. What is the conclusion at last? Data driven vehicle performance testing is redefining how vehicles are developed, tested, and optimized. By leveraging the power of sensors, telematics, machine learning, data analysis, the automotive industry is making significant strides toward creating safer, more efficient, and high-performing vehicles. As technology continuously to evolve and possibility to for enhancing vehicle performance through the data-driven testing are limits, paving the way for the next generation of automatic innovation. Next, we will go like we will go to next testing how electric vehicle battery, because if we have data, we informed how we are using those data to improve our vehicle testing, improve our vehicle behavior, improve our vehicle aggregate lives performance, improving consumer satisfactions. So now how we are testing new technology of vehicles, EV vehicles. So just to understand in EV, how we are using the EV battery testing data, just I want to provide you a small glimpse. Because the testing of EV vehicle is big chapter, but within short time, just I want to tell you, just I want to introduce you how we are using the data in EV battery testing. Then you can understand how much important the data in new technology for new developments. Electric vehicle battery testing is a critical ensuring performance, safety, longevity, efficiency of the EVs. Battery testing data provides valuable insights into how well the battery performs and under different conditions, helping manufacturers to optimize battery design, improve energy storage, and predict maintenance needs. This data can also be used to enhance vehicle performance, improve consumer satisfaction, and reduce operational costs. Here, how EV battery testing with help of data. Data collection from battery testing. EV battery testing involves collecting data from various tests that simulates real-world driving condition and operational stresses. The main type of tests typical performs are for only for battery. For vehicle, there is so many testings are there. These testings are only we are using for battery system, battery management system, BMS testing. Capacity testing. First, we are measuring how much energy the battery can store and discharge under different conditions. Like full charge condition, how much discharge is there? Partial charge condition, how much discharge is there? And also when high volt, low volt temperatures and different temperatures, high temperature, low temperatures, how the battery capacity is behaving, how the energy is discharging, those things we are testing with help of battery testing. We are collecting those data, and with help of the data, we are improving the battery life. We are improving the battery performance. Cycle life testing assesses how many discharge cycle a battery can go through before performing degrades. Like when you are charging, there is so many chemical reactions, temperature reactions are happening inside the battery. So how much time you can charge the battery in high voltage, in low voltage, those testing cycles were continuously performing in battery, and we are calculating this battery after certain this much cycle, the degradation of battery started. So till that, what we are doing, we are checking the life cycle of battery. Temperature performance. monitors the battery performance across a range of temperature, including high heat, extreme cold, on which impact charging speed, efficiency, and longevity. Discharge and charge efficiency. It measures the battery ability to release and store energy during the charging and discharging processes. State health of testing. It determines the current health of battery by comparing its performance and original specification. Voltage and current monitoring testing. It tracks voltage and current during charge and discharge of cycle, ensures the battery operates within the safe limits. Fast charging and range testing. It's evaluating the efficiency of fast charging system and how much range the battery can provide on a full charge. How much charge is coming from charging area and how much it's reaching to vehicle charging near to battery. So the loss in between from charging area to battery charging station, that also we are calculating with help of this data technology. Next, data analysis, key metrics, insights. Once data is collected, and the key is to analyze the understand and performance characteristics and health of the battery. Some of the important metric is in focus, like energy density. Higher energy density indicates that a battery can store more energy relative to its weight of volume. This directly impacts vehicle range and the performance of EV vehicles. That's why we're doing range testing. With help of this range density only, we can understand the battery how much energy can store. With help of this much weightage, or with help of this much volume, this much dia, this big size, how much energy can store inside the battery, we can simulate, and we can understand how much range will come when the vehicle will run in the certain speed, in certain road condition. Next, Coulombic efficiency. This measures the ratio of charges discharges versus the charges applied. A higher value indicates the battery is more efficient to storing and using energy. State of charge. The state of charge indicates how much charge remains in the battery. By monitoring the metric, engineers can predict the remaining range and the need of charging. How much charge is required, based on that you can decide. This is called SOC, state of charge, and state of health. State of health is nothing but battery health. The key performance indicators. State of health shows the battery health compared in original specification, which helps estimate how much life is left in the battery. Internal resistance. See, resistance is the major part of the battery energy system. High internal resistance can lead to more energy loss and inefficient performance. By analyzing this, engineers can detect the potential issues with the battery's structure and chemical chemical compositions, and they can improve the product on which how much chemical composition is required, or the structure. Like now came battery blades, it's in size it's very less, and range its energy is more, energy is storage capacity is that high. With help of this chemical composition changes and the amount changes, it's helped to reduce the battery size, developed a new battery segment, it's called blade battery, and it's revolutioning that electric vehicle segment in car and in commercial vehicles. With in less area, is high energy saving and high range is also coming. Temperature data is one of the main key factor of battery. Which one is helping to increase the battery charging, discharging, and the range range segment. Okay, temperature data. Monitoring battery temperature during charging and discharging helps identify potential thermal runaway risk of areas where temperature control may need to improve. Using battery testing data to implement the insights can like multiple layers, optimizing battery designs. How it's what the data we captured, how it's helping us to improve the battery design. Optimizing battery design is the first key parameter. Manufacturers can test the data to refine battery chemistries, designs, and systems. For example, if testing reveals high internal resistance or poor thermal performance, adjustment can be made to improve efficiency, cooling systems, and materials. With data-driven insights, the battery can be designed to improve the energy of density, cycle life, and overall performance. Next one is improving charging system. How we will improve our charging system, because in EV vehicle measured is for charging timeline. If it's taking more time slow charge, then it's not fit for market. To fit for market, to understanding the you need to improve the charging system. Charging system is play crucial role in battery performance and longevity. Battery testing data helps developers understand the ideal charging rate of batteries, whether it's low or fast charging. Detecting overcharging risk and ensuring potential charging times, the data can be used to develop battery charging protocols, algorithm, improving battery longevity and vehicle convenience. Predicting battery lifespan and maintenance needs. By monitoring the state health life cycle, it's possible to predict when battery will need replacement or when certain components may begin degrade. This allows for predictive maintenance practices where owner can be notified in advance about potential issues. Early detections problems can help reduce downtime and extend the battery usable life. Enhancing battery range prediction. Battery performance data combined with vehicle data can be used to create more accurate predictions and EV ranges. For example, by factoring the battery age, deriving habits, when one vehicle complete range came, no, after that we are dismantling the battery. We are checking how is the battery chemicals compositions happen after this much cycle with this much overloading or overcharging, fast charging. How is the battery chemicals reaction happen? How is the temperature reaction? All the data we are capturing. At final, we are checking how is the battery is now look like. So, moreover, accurate estimate of remaining range can be displayed for the drivers. This improves user experience and reduce range anxiety. Just hold a second.
Okay, no issue.
Thank you, Tim. Sorry, battery charge is less, so that's why.
No, it's not a problem.
Okay, next. With help of this data, during testing, we are utilizing, calculating, and setting the algorithm, which one is enhancing battery range predictions. Battery performance data combined with vehicle data can be used to create more accurate prediction and EV range. For example, by factoring the battery age, driving habits, and environmental conditions, more accurate estimates of remaining range can be displayed for the drivers. This improves the user experience and reduce the range anxiety. Range anxiety in the sense, like, I think all the people's, all the colleagues know, like how much distance my EV vehicle will go, when the battery will stop, those things. When you are running a EV vehicle, continuously it's come in your mind, because where is the charging station, how much my vehicle now it can run, where I will charge, how much time it will take. That is called range anxiety. So with help of the battery performance data, with combining vehicle data means on which speed you're going, on which application you are going, how much you're braking, how much you're steering, what are the things are you're running during vehicle run, like wiper motors, headlamps, tail lamps, side indicators, AC, and other sensors, other facilities, other features are in vehicle. So those are all vehicle data. We are compiling with the battery performance data, and we are creating more accurate and predicting the vehicle range. And it's helping you to reduce the range anxiety. Enhancing vehicle performance. Battery testing data such as charge, discharge, curves can be used to tune the vehicle energy management system for optimal performance. It can improve the distribution of power to the motor, enhance the generative braking system, regenerative braking systems, and fine-tune the power consumption during various driving modes, like eco mode, sports mode. So to understand you, just I want to describe, like battery testing data when we captured, like suppose there is a different road condition, A class road, as per testing. Okay, A class A class road in the sense where is the you can run the vehicle non-stop, plain clean road with the speed of more than 60 kmph. That is called A class road. If the road conditions are worst, there are so many potholes, but you are running in speed of 60 kmph, that is not called A class road. For A class road, the quality of the road condition is completely different. In that condition, when the vehicle running in this, so how we are testing, just I want to tell you. We will run the vehicle in 60 kmph continuously. Once we will full charge, then we will run till the dead of vehicle. Then we will identify a range. Like suppose example, if I will fully charge one EV vehicle and I will run the vehicle for 60 kmph continuously, and after 350 kilometer, my vehicle is completely shut down. Okay. Then next cycle, what I will do, I will run the vehicle in 70 kmph. Next cycle 80 kmph. Next cycle till max speed. I will run and I will identify the range, how much range coming on which speed for this road condition. Then what I will do, this is called high speed road, highway road. Then I will go for the B class road. Then I will go for C class road. Then I will go for inside city, like traffic condition, I will run the vehicle. In high speed, what will happen? Highway, what will happen? That is high speed road only. In highway, mostly there is no traffic. Still run in high speed in non-stop. But when go to city condition, in city traffics are there, speed breakers are there. Suddenly someone coming, some people are not understanding the traffic rules. So in that condition, we will simulate how much this range coming in this much capacity of battery, and all the captured battery capacity data, we will compile all the data. We will combine with the vehicle data, and we will recreate a software which will help when vehicle manufacturing. It will help want to go on which speed, when you want to brake, all those things. It will help, and it will predict how much battery charge will come for how much kilometer. So it will help the customer and also testing and for new developments, enhancing the vehicle performance. Also, like this much charging time, this much discharging time, this much energy management. If those energy management system data, if you have, it will help you to it will help you to define the range. If you go to eco mode, how much range will come? If you go to sports mode, how much range will come? When 4 people are sitting, how much range will come? When single driver only running, that much, how much range will come? So it's helping, simply it's helping to customers. Next, we will go data for post-production and end-of-life assessment. So EV battery testing data is not limited to production phase. Over the battery life cycle, this data remains valuable. After sales supports also, this data is helping post-sale vehicle diagnosis and troubleshooting. If customer reports battery issue, the data can be used to analyze pinpoint accuracy causes, what caused the failure happened. It's easily you can predict. It's helping battery recycling, it's helping battery diagnosis, degradation insights. Those data tests like life cycle voltage drops, essentially understanding the battery degrades over time. It helps improve future battery designs and long range battery production, and improve the long range battery throughout their span of life. Tool for handling and analyzing EV battery data. To make the most EV battery testing data, manufacturers and engineers typically uses specialized tools like battery management system. Battery management is one software constantly monitor the health of battery, voltage of the battery, temperature of the battery, and it's provide the real time insight during testing in use condition. Data analysis softwares, tools like MATLAB, Python, and other specialization batteries. Its simulation is kind of one software simulation which uses range amount of testing data. These tools helping to visualize the performance trends and predict the future performance. Also, cloud-based monitoring, like all the data come to cloud surface, where saving all the data and it's transmitting to centralized system. It's enabling the data analysis and across the multimedia vehicles, providing long-term insight for fleet management. So what we understanding after those software, sensor, and data. Finally, what we understand, EV battery testing data is a vital asset for the manufacturer, for the engineer, for the consumer, and for the customer. By the collecting, analyzing, applying these data, vehicle performance, safety, and efficiency can be improved, whether it is optimizing battery design, whether improving range estimates, or predicting maintenance needs, or exiting the battery lifespan. Proper utilization of the data will be central to the future of electric vehicles. As battery technology continues to evolves, and role of the data-driven testing will be only increase, drive automatically industry towards smarter, greener, and more efficient solutions. It's create more jobs, It's helping more engineers. It's helping the students to understand the vehicle design, the vehicle performance, vehicle behavior. Okay, thank you so much for the time. And Satyan sir,
हाँ मदन
so
सर, yes sir.
today's session this much. Hope
Okay.
my session understanding how data is important for new testing or not only automobile segment, for any product improvement, and also how data is important, how data is manipulating everything. So definitely data is required, and how we can utilize the data in positive way. That is the more
Correct.
important, more responsibility for our all students, all the citizen of our country. So it will help for fast moving
Obviously.
India. Thank you so much.
Thank you too, sir, for giving insights on the importance of data in testing of electric vehicle. If participants, if you have any doubt, please come forward. Okay. Uh, Amit sir, I don't have any question yet.
Mm.
Okay,
Uh,
so I would request Dr. Amit sir for a vote of thanks. Amit sir.
Thank you. Thank you, Satya sir. Am I audible, sir? I
Yes, yes,
just
yes.
put the
Perfect.
ear.
Yes, sir. Yes.
So, Madan Mohan Jena, sir, was very wonderful session that you have mainly highlighted the data system, how the data is important for us. What is the importance of the data in this automobile sector? You are very precisely and clearly explained that how the data of any automobile concern data is affect the vehicle performance, and that EV battery testing data is also how is important for electric vehicle that you have proved in this session. So definitely participants that noted the things and definitely they just get a spark in the direction of that data, so that we will also feel that the data is a very important part. And uh, from the behalf of the Sage University Mechanical Department and Department of Advanced Computing, thank you very much for sparing the precious, valuable time for us. And definitely, next meeting will be at Sage University for your junior student for guiding the electric vehicle. So be ready, Madan Mohan Jena sir. Thank you very much.
Thank you, Madan sir, for sparing your valuable time in the evening time, as you are very busy during that time. But you accepted our invitation and available here for delivering this such a nice session, sir.
Thank you, sir. It's my pleasure to discuss with you, discuss this big team, and sharing my experience. Hope my experience, my knowledge will help to our colleagues for upcoming
Definitely.
Definitely.
studies.
Yes.
Sure,
Yes.
sir. Definitely, sir. So, with this, um, should we close this meeting? Amit sir, or any other point
Yes,
you
sir.
wanted to add?
Yes. Now we close the meeting. Yes, sir.
So, thank you all the participants and speakers, sir. So, I'm just closing this meeting for all. And tomorrow we need to join early in the daytime. That is around 2 p.m. Tomorrow there will be three sessions back to back, and after that there will be a test and feedback session, and at the last there will be a valedictory session. So I request all of you to join early around at 2 p.m., and I will inform you the correct time in the our WhatsApp group. So thank you everyone. I am closing it.